Okay, we have started discussion on that Einstein coefficient, and Einstein coefficients, right? Okay, so we end up with this equation, right? The energy density of incoming photon as a function of angular frequency, and that was, if you remember, it was A21 divided by B21, then N1 by N2, then you have B12 divided by B21 minus 1, right? So this is your equation. Now, one thing you have to keep in mind, that suppose you have a two-level system. Suppose you have a two-level system, E1 and E2. Okay, so this is your system, and the temperature of the system is T. Temperature of system is T. Separation between these two levels is delta E, and that is of the order of H cross omega. And the population at E2, that is N2, and at E1, that is N1. According to Boltzmann distribution law, according to Boltzmann distribution law, ratio of population between two levels, N2 by N1, that will be how much? That will be exponential minus energy separation between two levels. That you have to keep in mind, that ratio of the population N2 by N1, that will be exponential minus energy separation between two levels divided by Boltzmann constant Kv and the temperature of the system. So this formula itself is important for GATE exam. So they will provide you system temperature and energy values, and they will ask you that ratio of population in these two levels. Okay, so this ratio I'll use here. So N2 by N1 is exponential minus E2 by E1, E2 minus E1 divided by KVT. So but further what I can write, that N1 by N2, that will be how much? So just it will be exponential of E2 minus E1 divided by Kv into temperature of that system. And E2 minus E1, that is nothing but much delta E, and further delta E is how much? H cross omega. So what I can write here, that this is nothing but exponential H cross omega divided by Kv into T. Okay, so just I'll use this values here. Then what I can write, that energy density of EM radiation, it will become U of omega. Okay, and that will be how much? A21 by B21. Then you have what? N1 by N2, that is nothing but, or I can write this term first. So I'll write this term first, B12 by B21. Then you have N1 by N2. Just I have written this term first, then I'm writing this. I can write, right? Because this is multiplication factor. So N1 by N2, just we have derived, that is nothing but H cross omega by Kv T. Then you have minus also, minus 1, right? Now, according to Planck's law, according to Planck's law, the energy density of photon as a function of angular frequency. If you remember that black body radiation, that time we have derived this formula. Okay, that energy density of photon as a function of angular frequency of that photon, and that will be how much? Remember, that was nothing but h cross omega cube divided by pi square d cube, and you have exponential h cross omega by kbt minus 1. So from Planck's law, I can write that energy density h cross omega cube divided by pi square v cube exponential h cross omega divided by kbt minus 1. So this is in terms of angular frequency, but in terms of frequency, that becomes E as a function of nu, and that will be how much? 8 pi h nu q divided by v q exponential h nu by kVt minus 1. So this is in terms of angular frequency, this is in terms of frequency. What is v here? V is the velocity of electromagnetic radiation or velocity of electromagnetic wave in a medium. So this velocity I can write that c by n naught. Where? Okay. So this is the velocity of electromagnetic radiation or velocity of photons in a cavity, and I am assuming that n naught is the refractive index of this cavity. Refractive
So
index.
this is x times u nu.
No, this no.
Yes, sir.
Like this. So this is u of nu. U of nu means energy density of photon as a function of frequency. Energy density of photon as a function of angular frequency. But यहाँ से कभी यहाँ कन्वर्ट करने की कोशिश मत करना. You will not get. You will get a difference of 2-5 factor का problem आ जाएगा. Please don't try to convert from omega to nu directly. Please don't do like this. इस तरह से आपको यहाँ से डायरेक्टली यहाँ नहीं मिलेगा, क्योंकि ब्लैक बॉडी रेडिएशन का अगर फॉर्मूला देखोगे वहां पे एक, जब आप एनर्जी डेंसिटी लिखते हैं वहां पे एक डी ओमेगा का भी टर्म आता है. दिस साइड यू विल हैव एन ऑन डी ओमेगा टर्म एज वेल. ठीक है, तो मेरा सजेशन यही है, प्लीज डोंट ट्राई टू कन्वर्ट ओमेगा टू न्यू by using this formula. You will not get result of nu energy density as a function of nu from this formula. Please don't do this. Is it clear or I have to repeat?
Please repeat.
What I'm saying, according to Planck's law, the energy density of photon as a function of angular frequency, that will be h cross omega cube divided by pi square v cube exponential h cross omega by kVt minus 1. So this is in terms of omega. What is v? V is the velocity of photon inside that cavity. Cavity is nothing but you have a pair of mirrors and you have a active medium. So this is whole is nothing but cavity. जो आपका होल मिरर के अंदर जो आपका सिस्टम है, दैट वी हैव लाइक अ कैविटी. तो वहां पे जो आपका फोटॉन्स है उसका वेलोसिटी v है, and v is nothing but v is the velocity of photon inside this cavity, and if n naught is the refractive index of this cavity, then velocity of this photon inside cavity, that will be c by n naught. Okay, and n naught is the refractive index of this cavity. And most of the cases, if you see that problem, in most of the cases n naught will be how much? That will be on. So they used to write that is inside cavity you have nothing. But what I am trying to say, that we know this formula, omega equals to 2 pi nu. We know this formula, right? we know angular frequency, that is nothing but 2 pi times nu. So I can convert from omega to nu by using this formula. But this formula, if you use this formula here to convert from omega to nu, you will not get accurate result or exact result. आपको यहाँ से ओमेगा से न्यू में डायरेक्टली अगर कन्वर्ट करना चाहते हो यहाँ, यू विल नॉट गेट दिस रिजल्ट, आपको ये रिजल्ट नहीं मिलेगा. If you see that, if you look at that black body radiation derivation, then you can understand that this side you have on term d omega भी रहता है ना. तो डी ओमेगा को भी आप जब न्यू में कन्वर्ट करना चाहोगे तो इसको भी आपको क्या करना पड़ेगा, न्यू में कन्वर्ट करना पड़ेगा. So that's what I am saying, don't convert from omega to nu directly. ये आपको थोड़ा सा ये वाला पोर्शन आपको याद करना ही पड़ेगा. और otherwise you have to be familiar with black body radiation. There in that topic itself, we have directly or we have nicely derived this term, that how omega, this energy density of photon, used to come as a function of omega, how this energy density of photon used to come as a function of nu. Okay, अगर आप लोगों को confusion है, you can look that black body radiation chapter. Okay, you can see this thing. So I will not spend that much time here. Now what I'll do, I'll compare this and this, because these are same thing, right? U as a function of omega, both are representing the energy density of photon. So from here if I compare, then how much I'll get? यहाँ देखो B12 by B21 ये कितना है? If we compare this equation with this equation, then how much is actually B1 by B2? So this factor, if you see, this is exactly same as this. So here I can write 1 into exponential h cross omega by kVt minus 1. So this actually this value, and this A21 by B21, that is basically how much this ratio is, this factor. So can I write that A21 by B21 कितना आ जाएगा बताओ आप लोग? How much I'll get? Can you please tell me, anyone?
h का 2
8 pi h nu
divided by
cube
pi
by
square v.
So in terms of angular frequency, it will be h cross omega cube divided by pi square, and VQ is how much? V is nothing but C by N naught, right? So in place of V, if I write C by N naught, then I'll get C cube, and in numerator you will have N naught cube. So this is in terms of angular frequency, but if you calculate in terms of frequency, then how much it will be? So it will become same thing. It will become 8 pi. Okay, 8 pi, then h nu q into n naught cube divided by c cube. So this is in terms of angular frequency, and this is in terms of what? Frequency. Is this clear? मतलब इस इक्वेशन से भी कंपेयर कर सकते हैं ना, ये वाला इक्वेशन से. So this term is actually what? Same term. And on means this on is basically how much? This is nothing but B12 by B21. So A21 by B21 I can write h cross omega q n naught q divided by pi square c q, or I can write 8 pi h nu q n naught q divided by c q. And how much will be that B12 by B21? कितना आ जाएगा?
1.
Exactly. So it will be on. So what does it mean? That B12 equals to B21. So what is the meaning of that? B12 equals to B21. It means probability of stimulated absorption. B12 means what? This represent, B12 represent that probability of stimulated absorption. So probability of stimulated absorption is equals to the probability of stimulated emission. From this derivation, what we conclude, that probability of stimulated absorption should be same as probability of stimulated emission. Now just we have written that factor, right? A21 by B21, and that is nothing but H cross omega cube. Then you have N naught cube, right? Then you have C cube. So now if I multiply by H cross square, divide by H cross square, and if I bring this H cross square here, then what I can get? I'll get H cross omega cube, right? Then you will have N naught cube divided by C cube H cross square. And what is H cross omega actually? H cross omega क्या है?
Delta E.
Exactly. So A21 by B21, that is nothing, that I can write. So H cross omega ka cube. So H cross omega is nothing but delta E, separation between two level ka cube. So what is delta E actually? You have a E2 and you have a E1, right? And this separation, that is delta E, and that is nothing but H cross omega. So what is A21 actually? What is A21? A21 represent probability of spontaneous emission. B21 क्या है? अभी हम लोगों ने बोला था B12 इक्वल्स टू B21. इसका मतलब क्या है? प्रोबेबिलिटी, इसका मतलब ये है, ये जो है आपका प्रोबेबिलिटी ऑफ स्टिमुलेटेड एब्जॉर्प्शन. B21 जो है आपका, दैट इज प्रोबेबिलिटी ऑफ स्टिमुलेटेड इमिशन. A21 क्या है आपका? दैट इज प्रोबेबिलिटी ऑफ स्पॉन्टेनियस इमिशन. So from this equation, it represents probability of stimulated absorption is equals to the probability of stimulated emission. And A21 by B21, this is actually the ratio of probability of spontaneous emission to that of stimulated emission, and that basically depends upon delta E की power cube. अब लेजर लाइट के लिए आपको क्या चाहिए? A21 by B21 ज्यादा चाहिए या कम चाहिए? For laser light, that A21 by B21, will it be larger or smaller? What is the condition for laser? For laser light, तो आपको जितना possible है, you have to be minimize that spontaneous emission, because spontaneous emission will never help you to create high intensity, or spontaneous emission will never build up any intensity. Okay, so आपको ज्यादा से ज्यादा क्या करना पड़ेगा? स्टिमुलेटेड इमिशन को ज्यादा करना पड़ेगा. सो ऑब्वियसली आपको अब ये जो फैक्टर है, इस फैक्टर को आपको कम करना पड़ेगा, बिकॉज ये फैक्टर ज्यादा है. इसका मतलब क्या है? स्पॉन्टेनियस इमिशन विल बी डोमिनेटेड, है ना? दिस फैक्टर स्मॉलर देन 1, इट मींस दैट स्टिमुलेटेड इमिशन इज डोमिनेटेड. एंड फॉर लेजर लाइट वी एक्चुअली नीड stimulated emission that should be dominated. So to dominate that, you have to be this ratio that should be equals to less than 1. What I'm saying, this should be less than 1. क्यों? क्योंकि आपका प्रोबेबिलिटी ऑफ स्पॉन्टेनियस इमिशन आपको कम करना पड़ेगा, है ना? सो दिस रेशियो एक्चुअली डिपेंड अपॉन व्हाट फैक्टर? दैट इज बेसिकली डिपेंड्स अपॉन एनर्जी सेपरेशन बिटवीन टू लेवल्स. तो एक ही ट्यूनिंग पैरामीटर है जो आपका इसको कंट्रोल कर सकता है. वो कौन है? कौन है जो इसको ट्यून कर सकते हैं? दैट विल बी द सेपरेशन बिटवीन टू लेवल. तो आपको ऐसा मटेरियल चूज करना पड़ेगा लेजर लाइट के लिए जिसमें आपका जिसमें दो लेवल के कारण जो आपका लेजर मिल रहा है, लाइट मिल रहा है, दैट गैप शुड बी स्मॉल. दैट गैप क्या होना पड़ेगा? दो लेवल के बीच में ऐसा मटेरियल चूज करना पड़ेगा जहां पे आपका दो लेवल के बीच में क्या हो? गैप स्मॉल हो. व्हाई? If that gap is small, then delta E की power it should be small. Meaning delta E की cube, that should be small. So if this factor is small, what does it mean? If it is small, it means that probability of stimulated emission will be dominated as compared to spontaneous emission, and that is actually necessary condition to build up laser light. To produce laser light, you have to have material which should have that energy separation that should be small. Is this clear what I'm saying?
Yes, sir.
Okay.
Sir, how to dominate stimulated
Sorry, your voice is
because both have the same probability, na?
both. Oh, yes, yes. Both are same probability, but we know probability will not always help you to tell you that which one will be dominated. So for that we need this population inversion, right? N2 greater than N1. तो पहला तो कंडीशन ये होना पड़ेगा आपका, जब N2 ग्रेटर देन N1 है, इसका मतलब ही क्या है, ऑल दो प्रोबेबिलिटी कब आपका इक्वल है, जब N1 पे और N2 पे बराबर एटम हो, तब आपका क्या है, दोनों का प्रोबेबिलिटी सेम है. What I am trying to say, if you remember that rate of stimulated absorption, that was how much? That was B on 2 into B on 2 U nu और U omega into N1, right? ये आपका रेट ऑफ स्टिमुलेटेड इमिशन था और रेट ऑफ स्टिमुलेटेड एब्जॉर्प्शन था, इफ यू रिमेंबर. एंड रेट ऑफ stimulated emission, how much it is actually? Can you please tell me? This is your rate of stimulated absorption, if you remember. And rate of stimulated emission, it was like minus B2 on U of nu और U of omega into N2. तो आपको क्या देखना पड़ेगा कि कौन सा स्टिमुलेटेड इमिशन डोमिनेट है या स्टिमुलेटेड एब्जॉर्प्शन डोमिनेटेड है. तो आपको क्या देखना पड़ेगा, ये सारे फैक्टर को देखना पड़ेगा, क्योंकि दिस इज अल्टीमेटली डिफाइनिंग दैट नंबर ऑफ ट्रांजिशन, राइट? नंबर ऑफ रेट ऑफ ट्रांजिशन ये डिफाइन कर रहा है. ऑल्दो देयर प्रोबेबिलिटी इज सेम, U omega is same, but when N2 is greater than N1, इसका मतलब है आपका rate of stimulated emission will be dominated over rate of stimulated absorption. So for laser light, we already have discussed, to dominate the stimulated emission over stimulated absorption, we should have this condition. हाँ, अगर N2 N1 बराबर हो जाता, सपोज मान लो यहाँ पे N2 equals to N1 हो जाता, तब फिर क्या हो जाता? In that case, that rate of stimulated emission is same as rate of stimulated absorption. But for laser light, we must need N2 greater than N1.
सर मेरा क्वेश्चन ये है कि देखिए वी मतलब पंपिंग यूज करते हैं, हम पंपिंग है ना करके हम N2 ग्रेटर देन N1 करते हैं, है ना?
Yes.
तो मतलब जब प्रोसेसिंग ऑफ पंपिंग चल रही है ना, तो फोटोन आएगा और वो स्टिमुलेटेड अब्जॉर्प्शन भी हो सकती है. तब तो N2 ग्रेटर देन N1 हुआ ही नहीं अभी पंपिंग होके. तो तब मतलब ये पहले से ही कैसे हम लेंगे कि N2 इज ग्रेटर देन N1?
नहीं, पहले सब नहीं, पहले आपको N2 ग्रेटर देन N1 को अचीव करना ही पड़ेगा लेजर लाइट के लिए. सपोज मान लो इनिशियली आपका सारे एटम्स कहाँ पे है, E1 पे है, ठीक है, और E2 मान लो खाली है, बिल्कुल खाली है, सारे एटम सपोज मान लो आपका N1 यहाँ पे E1 पे सारे एटम्स, ठीक है. आप ऐसे इमेजिन करो कि सडनली आपके पास यहाँ पे कुछ एटम्स नहीं है, ठीक है. सडनली आपके सपोज मान लो कि यहाँ पे आपका सपोज मान लो 10 एटम है, सपोज मान लो आपके पास यहाँ पे 10 एटम है और आपने सडनली, और यहाँ पे कुछ नहीं है, आपने 6 फोटॉन्स को सेंड कर दिया, ठीक है. 1 2 3 4 5 6. तो 6 फोटॉन्स क्या करेगा, आपका स्टिमुलेटेड इमिशन तो कुछ होगा ही नहीं, सारे क्या होगा, दैट विल बी ऑब्जर्व बाय दिस सिस्टम, राइट? यॉन पे जो एटम्स है सिटिंग है, कितना एटम सिटिंग है, 10 एटम सिटिंग है. इनमें से 6 एटम 6 फोटोन को ऑब्जर्व करके पहले तो पॉपुलेशन इन्वर्जन को क्रिएट करेगा. पहले क्या हो जाएगा, आपका पॉपुलेशन इन्वर्जन हो जाएगा. आप यहाँ पे कितना हो गया, आपका 6 हो गया, ठीक, और यहाँ पे कितना है आपका 4 हो गया. तो पहले तो एक कंडीशन वो अचीव करेगा, उसके बाद आपका लेजर लाइट क्रिएट होगा.
ओके सर,
हाँ,
थैंक यू।
तो दोनों दो चीज आपका नेसेसरी है। पहले तो आपका पॉपुलेशन इन्वर्जन सबसे ज्यादा जरूरी है कि लेजर लाइट के लिए N2 को ग्रेटर देन N1 होना पड़ेगा टू डोमिनेट स्टिमुलेटेड इमिशन ओवर द स्टिमुलेटेड एब्जॉर्प्शन। सो दिस इज द फर्स्ट कंडीशन। दूसरा कंडीशन ये है कि एनर्जी सेपरेशन जो है दो लेवल के बीच में, जो हम E2 इॉन से डिनोट कर रहे हैं, है ना, दैट सेपरेशन आल्सो शुड बी स्मॉल। बिकॉज एनर्जी सेपरेशन ज्यादा हो गया, इसका मतलब क्या है, spontaneous emission is dominated over stimulated emission. Then again there will be problem in that system, because spontaneous emission will never help you to create or build up intensity. Okay, so only one option to tune this ratio, that is A2 on by B2 on, that is the energy separation. So energy separation should be small. You have to choose that material in such a way that energy separation between two levels that should be small. Okay, will it be remember in your life? You have to be remember
यस।
this. Okay, now if I compare, so you have a many part of EM radiation, right? If you remember, microwave, then you have IR, then visible, UV, X-ray, so on, right? If you remember that part of EM radiation, you have microwave first, then IR, infrared, right? Then visible, then UV, then X-ray. तो एनर्जी सबसे कम किसका होता है? माइक्रोवेव का, राइट? if I am compare, you have a microwave, then you have a IR. IR means infrared. Then you have a visible, VIS. You have a UV, and you have a finally X-ray. Okay. So माइक्रोवेव का एनर्जी सबसे कम होता है, राइट? तो माइक्रोवेव का मतलब क्या है? सपोज you have some materials with energy level E2 and E1. With energy level E2 and E1, and we can produce that microwave when that separation between E2 and E1 is small, है ना? कैसे create करोगे? When that atoms is at E2, when it will make transition to E1, and there will be emission of photon, and this photon will be microwave when that separation will be small. तो मेरा कहने का मतलब ये है कि माइक्रोवेव प्रोड्यूस करने के लिए जो मटेरियल चाहिए उसमें क्या है, एनर्जी सेपरेशन क्या होगा आपका, दैट शुड बी वेरी स्मॉल एज कंपेयर टू आईआर। जैसे आप आईआर में गए तो आईआर का जो एनर्जी है ईएम रेडिएशन का, दैट विल बी ग्रेटर देन माइक्रोवेव। तो इसमें जो आपका एनर्जी सेपरेशन होगा बिटवीन E2 एंड E1, दैट विल बी लार्जर एज कंपेयर टू, है ना? इसके कंपैरिजन में एनर्जी सेपरेशन ज्यादा होगा। फिर विजिबल में जाओगे, ये सेपरेशन और आपका ज्यादा होना पड़ेगा। एम आई करेक्ट और नॉट? आर यू एंजॉइंग व्हाट आई एम सेइंग? जैसे आपका कैसे आपका माइक्रोवेव क्रिएट होगा, you have some atoms, when that electron is making transition from E2 to E1, if this energy separation is small, then whatever photon you are creating, that is lie in this region. When that energy separation is higher than this microwave, then when there is a jumping from E2 to E1, these photons will belong to where? Higher range. Now if you further increase the separation between E2 and E1, okay, then what we'll get, when there is a jumping of electron from E2 to E1, and there will be creation of photon, and this photon will belong to visible range. Now if you further increase that separation, if you increase that separation more, then jumping of atoms from E2 to E1, that will produce UV. Now to produce X-ray, you have to increase the separation further. Right? So you have here that separation is delta E. Now can you please tell me, ये separation किसका सबसे कम है? माइक्रोवेव के लिए जो सेपरेशन है सबसे कम है। तो सबसे if I am writing that ratio A2 on by B2 on for microwave, तो ये सेपरेशन किसके ऊपर डिपेंड करेगा? डेल्टा ई की पावर क्यूब, राइट। सॉरी, ये जो रेशियो है A21 by B21 किसके ऊपर डिपेंड करेगा? डेल्टा ई की पावर क्यूब, राइट। So this ratio A21 by B21 for microwave, it will be smallest among all this region, right? So this A21 by B21 for microwave, it will be smallest as compared to A21 by B21 for IR. Further, this will be smaller. A21 by B21 for IR range, it should be smaller as compared to visible range. So I can further write A21 by B21 for what? Visible. Okay. फिर ये जो रेशियो है विजिबल के लिए कम होगा एज कंपेयर टू व्हाट? A21 by B21 फॉर यूवी। एंड सबसे ज्यादा किसका होगा? दैट विल बी फॉर एक्सरे। क्या वाला पार्ट समझ में है आप लोगों को?
यस सर।
ओके, नाउ कैन यू प्लीज टेल मी, सपोज मान लो आप माइक्रोवेव लेजर बना रहे हो, आईआर लेजर बना रहे हो, विजिबल लेजर बना रहे हो, यूवी लेजर बना रहे हो, एक्सरे लेजर बना रहे हो, है ना? किसका इंटेंसिटी सबसे ज्यादा होगा?
माइक्रोवेव का।
एग्जैक्टली, माइक्रोवेव का सबसे ज्यादा होगा, क्योंकि माइक्रोवेव का ये जो रेशियो है वो स्मॉलेस्ट है। स्मॉलेस्ट है इसका मतलब क्या है? ये जो स्टिमुलेटेड इमिशन है ये डोमिनेटेड है, ठीक है। तो माइक्रोवेव का जो इंटेंसिटी होगा, इंटेंसिटी ऑफ माइक्रोवेव लेजर दैट विल बी हाईएस्ट देन इंटेंसिटी ऑफ आईआर लेजर, देन इंटेंसिटी ऑफ विजिबल लेजर, इंटेंसिटी ऑफ यूवी लेजर, बट यू विल नेवर गेट एक्सरे लेजर। कभी पॉसिबल नहीं है एक्सरे लेजर बनाना। एक्सरे लेजर बनाना कभी पॉसिबल नहीं है, क्योंकि वहां पे स्पॉन्टेनियस इमिशन इतना डोमिनेटेड होता है, यू विल नेवर बिल्ड अप एनी इंटेंसिटी। So it is not possible to produce X-ray laser, and the intensity of microwave laser will be highest among all lasers. Why? Because stimulated emission is strongly dominated over spontaneous emission, and that is actually needed to produce a high intensity light. Is this clear what I'm saying? Tell me if you have any doubt. You have doubt? Please
Yes,
tell
sir.
me. Please
Yes,
tell
sir.
me. There should be some question. You know, this is a very interesting part is going on. So I'm expecting few questions as well. So if you have no question, I can erase and I can further proceed. Shall I erase this part? Shall I erase?
Yes, sir.
So you have to keep in mind that you cannot produce that X-ray laser, okay? And the intensity of microwave laser is highest. Okay. Now you can further mention. You can further mention at thermal equilibrium. At thermal equilibrium, comma, the ratio of number of at thermal equilibrium, the ratio of number of spontaneous emission.
सर
Hmm.
हेलो, ये कह रहे थे ये एक्सरे रीजन में
Hmm.
अगर बहुत ज्यादा फाइनाइट टेम्परेचर करके N2 के प्रो N1 से ज्यादा नहीं कर सकते हैं पॉपुलेशन इन्वर्जन E2 में।
अच्छा, N2 को ज्यादा, हाँ, what you are
अगर
saying,
इनफाइनाइट टेम्परेचर अप्लाई करके,
you are saying that we cannot, we can achieve this, right?
हाँ, एक्सरे रीजन में अगर टेम्परेचर फाइनाइट इनफाइनाइट दे
Okay,
रहा है।
yes, sir, definitely you can, then what will happen, that your stimulated emission will be dominated over stimulated absorption, right?
यानी स्टिमुलेटेड इमिशन की प्रोबेबिलिटी को बढ़ा सकते हैं ना स्टिमुलेटेड.
No, that it doesn't depend upon, you see, this to dominate that stimulated emission over spontaneous emission, it is not depending upon population. It is only depending upon what, if you see that derivation, A21 by B21, you will never have any term that depends upon number of population. It is only depend upon the tuning parameter is only all about your energy separation between two level. इस रेशियो को ट्यून करने के लिए यहाँ पे N1 and N2 का कोई रोल नहीं है. N2 को ऑब्वियसली ज्यादा करना पड़ेगा. क्यों? क्योंकि आपको स्टिमुलेटेड इमिशन को डोमिनेट करना पड़ेगा एज कंपेयर टू स्टिमुलेटेड एब्जॉर्प्शन, है ना? क्योंकि जैसे आपका, हाँ, बट ये रेशियो ट्यून करने के लिए एक ही पैरामीटर है, दैट इज द सेपरेशन बिटवीन टू लेवल्स. ऑफ कोर्स यू कैन पंप दैट नंबर ऑफ एटम्स फ्रॉम N1 to N2 at very high temperature and you can achieve this when you have a very large separation. But to tune this parameter only on quantity is there, that is delta E. So delta E ko you have to make small. Otherwise, spontaneous emission will be dominated.
Okay, sir.
Sir, by which condition, मतलब if we want ki delta I to, by which condition we, if we want to minimize somewhere ki hanji asi that we want to make a.
Sorry, can you please repeat your question one more time? So I am
Sir,
not.
sir, in some cases, like there is not much, delta is very large or quite large, but we want a laser action to happen, है ना? And for that, delta E should be small. So can we मतलब make delta E small by some condition? Can we do that?
Yeah, you can do that. Suppose I am giving you example. You will never get a laser light from Al2O3, aluminum oxide, because their energy separation is very large. Energy separation between two levels is very large. But if you dope chromium ion here, okay, chromium 3 plus in place of aluminum, then you will have that energy separation between two level that will be small, and you can produce laser. So by making, you know, that semiconductor, right? If you make that doping, that energy separation will be small. Are you familiar with this? To control that energy separation between two levels, on tuning parameter is known as, that is known as doping. In my research also, I have done this kind of thing. To make that energy separation, to tune this separation, I have used the doping parameter. Okay, because one thing, you know, on material, I'm not going that in details. There is a one material, you know, zinc oxide. Are you familiar with this? Zinc oxide, there is a material, it has very large band gap. So there is a problem to use this material for optoelectronic applications, especially photovoltaic and other optoelectronic applications, because of very high separation between ion and E2. So to reduce this separation, what I have done different doping in place of zinc oxide. So you can tune this separation.
सर देन तो जो हमने एक्सरे के लिए भी तो हमारा यही प्रॉब्लम है ना, देयर इज अ लार्ज सेपरेशन बिटवीन द टू
When you will,
लेवल्स.
हाँ, जैसे आपने उसको सेपरेशन को कम कर दिया, then it will no longer be belongs to X-ray. That will
ओह
belong.
या ओके.
Okay. Now what I'm saying, at thermal equilibrium, the ratio of number of spontaneous emission. SP means what? Spontaneous emission to that of stimulated emission. Okay, this ratio, and in mathematical form, the ratio of spontaneous emission to that of spontaneous emission, to that of stimulated emission. In mathematical form, how we used to write, that is nothing but number of spontaneous emission, that is A21, and number of stimulated emission, that is nothing but B21 U of omega. So this thing is actually representing the ratio of number of spontaneous emission to that of stimulated emission. So at thermal equilibrium, this ratio will be how much? A21 by B21 U omega. कितना आ जाएगा? If you remember, we have this was your equation. U of omega, that was how much? A21 by B21, and you have this factor H cross omega by KBT minus 1, and B1 by B2, that is nothing but that is on, we know this, right? And that B1 by B2, that is on. So from this expression I can get that A21 divided by B21 U omega, that will be how much? कितना आ जाएगा?
e की power h cross omega by kbt minus 1.
Exactly, H cross omega by KBT minus 1. So this actually representing the ratio of number of spontaneous emission to that of stimulated emission. Okay, and that depends upon exponential H cross omega by KBT minus 1. Okay. Okay, for example, suppose you have a system. Suppose you have a system having temperature 1000 Kelvin and angular frequency is 3 into 10 to the power 15 second inverse. Now, can you please calculate this ratio of number of spontaneous emission to that of stimulated emission? So it will be how much? Ratio of spontaneous emission to that of stimulated emission. That will be how much? Exponential H cross is how much? That is 1.05 10 to the power 34. Omega is given 3 into 10 to the power 15. Then you have a kV. kV is how much? 1.38 into 10 to the power minus 23. And then finally you have a temperature, that is how much? Kitna hai temperature? That is given 10 to the power cube. 1000 means what? 10 to the power cube. And finally you have this minus 1 also. Okay. So if you calculate this value, you will basically get 10 to the power 10. It means if you have a optical source having temperature 1000 Kelvin and angular frequency 3 into 10 to the power 15 second inverse, in that situation, spontaneous emission is strongly dominated over stimulated emission. So this representing number of spontaneous emission and this representing number of stimulated emission, and you can see this ratio is 10 to the power 10. So at this parameter, spontaneous emission is strongly dominated over stimulated emission. Is this clear what I'm saying?
Yes, sir.
Okay. Now you have to calculate, or you have to find, suppose this is your homework, please do it. Okay. Suppose you have a optical source having temperature 1000 Kelvin. So at what frequency this number of spontaneous emission to that of stimulated emission, that becomes on? At what angular frequency this ratio will become on, that you have to calculate. And temperature again is how much? That is 1000 Kelvin. Can you able to solve? Please do this homework. Okay. Shall I proceed? Can you able to solve this?
Yes, sir.
Okay, let us solve few problems. Okay. Suppose you have a two-level system. You have a two-level system, E2 and E1. And this system is having a refractive index is given, that is N naught equals to how much? That is 1. Okay. So when that electron or atoms is making transition from E2 to ion, it will emit photon. The wavelength of this photon is given, that is 3000 Armstrong. Okay. 3000 Armstrong is given, that wavelength of photon. And also coefficient of stimulated emission is given. Coefficient of stimulated emission, that is given 2.1 into 10 to the power 19 in SI unit. In SI unit. Okay. Then what you have to calculate? You have to calculate the lifetime. You have to calculate the lifetime of E2 is how much? Again, I am repeating, you have a two-level system having refractive index how much? N naught, and that level is E1 and E2. When that atoms is making transition from E2 to ion, it is emitting photon having wavelength 3000 Armstrong. The coefficient of stimulated emission is given 2.1 into 10 to the power 19 in SI unit. You have to calculate that lifetime of level E2. How will proceed?
Eight pi h. A21 by B21 is equal to 8 pi h.
Exactly. So we know this relation, right? A21 by B21. That is how much? When N naught equals to 1, then I can write this is nothing but, in place of N naught, if I write N naught equals to 1, then it will be 8 pi h nu q divided by CQ, right? And we know nu is nothing but C by lambda. Nu is nothing but C by lambda. So if I substitute that in place of nu, if I substitute that C by lambda, it will be basically 8 pi h CQ divided by CQ into lambda q. So this CQ will be cancelled. And you have a, this is your what? This is your A21 by B21. And we know that lifetime of level E2 is nothing but what? So you know this formula, right? A21 is nothing but 1 by tau sp And this tau sp is actually lifetime of level E2. So in place of A2 if I substitute on by tau sp, then this tau sp you have to calculate, and this is actually the lifetime of level E2. So if it means if I calculate the tau sp, if I arrange this equation, so your equation is what? 1 by B2 on tau sp, that is equals to how much? That is equals to 8 pi h divided by lambda q, right? So if I write in simple way, that is B1 by B2 on, then you have a tau sp, and that is how much? That is actually 8 pi h divided by lambda q. So it means tau sp will be how much? It should be lambda cube divided by B2 on, and you have 8 pi h. And we know every parameter now, just I'll substitute that. So lambda is how much that they have given, that is 3000 Armstrong, right? So I can write 3000 into 10 to the power minus 10, and there is a cube. Then you have 8 pi is 3.14, h is how much? 6.6 into 10 to the power minus 34. Then you have a B2 on. B2 on is how much? 2.1 into 10 to the power 19. So 3000 into 10 to the power minus 10, because this is in Armstrong, so obviously you have to multiply by 10 to the power minus 10. You have a cube, so this is a cube. Then 8 pi, 8 into 3.14, h is 6 into 6.6 into 10 to the power minus 34, and B21 is given, that is 2.1 into 10 to the power 19. Okay. So if you calculate this, if you solve this equation, it's a very simple mathematics. Basically, we'll get 77 nanosecond. So lifetime of this level E2, that will be how much? That will be only 77 nanosecond. Is this clear?
Yes, sir.
Okay. Okay. Next problem, problem number 2. Suppose you have a 4-level system that is given 0, on, 2, and 3. So this is basically 4 levels system, right? That atoms from 3 can jump from 3 to 0 with spontaneous emission coefficient, you know. Atom can jump from 3 to 0 by spontaneous process, and the coefficient of spontaneous is given, that A30. That is how much? A30 is given, that is 4.5 into 10 to the power 6 second inverse. Further, these atoms from level 3, from this level it can jump to 1 as well by spontaneous process. So it can jump from 3 to 0 by spontaneous process with this probability. When it is jumping from 3 to 1, the probability of spontaneous emission that is given, that is 3.5 into 10 to the power 6 second inverse. Okay.
Sir,
When
A30 is 4.3 or 4.5?
4.5.
Okay, sir.
4.5, then 3.5. Now when it is jumping from 3 to 2 by spontaneous process, the probability is given, that is A32, and that is basically 2 into 10 to the power 6 second inverse. And there is other process also given, 2 to 0, the spontaneous probability, that is A20, 2 into 10 to the power 6 second inverse, and 2 to on with probability of spontaneous emission that is given on into 10 to the power 6 second inverse. So this kind of diagram is given that atoms from 3 can jump from 3 to 0 with spontaneous probability 4.5 10 to the power 6 second inverse, 3 to 1 with this probability, 3 to 2 with this probability. And further, these atoms can jump from 2 to 0 by this probability, 2 to 1 by this probability. And this is all about your spontaneous process. The question is, you have to calculate that lifetime, a lifetime of level 3. What you have to calculate? That lifetime of level. Can it be possible? So net probability of spontaneous emission is how much? Net probability will be how much? So net probability of spontaneous emission of level 3, that will be A, and that will be sum of A30 plus A3 on plus A3. This is the net probability of spontaneous emission of level 3. It can jump from 3 to 0 or 3 to on or 3 to 2. So or means what? Or means you have to add that probability, right? So it can jump from 3 to 0 or 3 to 1 or 3 to 2. So with these probabilities, and whenever you that or term used to come, you are familiar with this OR gate, right? So or means you have to add this probability. Or means you have to add that probability. So net probability of spontaneous emission of level 3, that will be how much? A30 plus A3 on plus A3. So net will be how much? कितना आ जाएगा चेक करो. So A30 is given, that is 4.5, and then you have a
10 to the power 18, 10 into 10 to the power 18.
okay, let me check. 4.5 plus 3.5, then you have how much? Then you have a 2, and you have this 10 to the power 6 second inverse, right? This is common from all, and this 4.5 plus 3.5 plus 2. So this is your 8 plus 2, 10. So this is your 10 to the power 7 second inverse. So this is the net probability of spontaneous emission of level 3. So now I can calculate that lifetime of level 3. So this is 1 by A. Okay, and A we know, so this is nothing but 1 by 10 to the power 7 second. So basically this is 10 to the power minus 7 second. Okay, is this clear to all?
Yes, sir.
The tau SP is 1 by A from previous relation here.
We have derived. If you remember,
Okay.
we have derived this, right? In previous class. That time itself, I told you, you have to be remember, because this is important for your exam. That spontaneous lifetime is inversely proportional to probability of spontaneous emission. Okay. Now there is another problem. Suppose you have a hydrogen atom. Suppose the hydrogen atom, you have a 2p state and you have a honest state. And this atom is actually in a medium, and this is actually air. And the refractive index of this medium N naught, that is 1. Okay. So hydrogen atom is basically where it is at air. And this is the state 2p and honest state. Obviously 2p is excited state. The separation between these two states is given. That is 10.2 electron volt. and also lifetime of this level is given 2p. Tau sp is given 1.6 nanosecond. Okay, 1.6 nanosecond. Yes.
So please repeat the question. Your voice
Ah.
was not audible my
Yes,
side.
yes, yes. So you have basically you have a hydrogen atom. This is at AR. Okay. So it means that atom is where at AR refractive index कितना है? N not equals to 1. Separation between two level. This is the 2p level of hydrogen atom and this is the honest. Obviously, this is the ground state. Separation between these two level is 10.2 electron volt, and spontaneous lifetime of 2p level is 1.6 nanosecond. Okay. From this information, you have to calculate the ratio of probability of probability of stimulated emission to that of spontaneous emission. That you have to calculate. Can you able to solve? So you know this relation, right? If you remember that A2 on divided by B2 on, that is how much?
Delta E करके
H cross omega cube divided by pi square C cube. Because here you have N naught cube term also, but N naught is how much? On. So basically I can write this is on. So this will be your equation. Now this equation further I can write. I can multiply by H cross square and I can divide by H cross square. Now if I combine these terms, then on numerator you will have H cross omega power cube. So that is nothing but delta E ki power cube. So what I can write in numerator you will have delta E ki power cube. Okay. And in denominator you will have H cross square pi square C cube. Okay. But they ask to calculate B21 by A21. Just I'll reverse it. So further I can write B21 by A21. And that should be equals to H cross square pi square C cube divided by delta E ki power cube. Right? Now just I'll substitute that value. So this question asked in net itself. Okay, so B21 by A21, that will be how much? Pi square, H cross square, that is nothing but 1.05 into 10 to the power minus 34 ka square, right? Then pi square, it means 3.14. 3.14 ka square, then C cube, it means 3 into 10 to the power 8 to the power cube. Okay. Then further what you have? Delta E, and that is how much? Delta E कितना है भाई? कितना है delta E?
10.2
Exactly. 10.2 electron volt. So this is 10.2. From electron volt you have to go to SI unit, right? Because they ask you to calculate this ratio in SI unit. So everything I have written in SI unit. So I have to write this also in SI unit. So from electron volt you have to go to where? Volt. So how will go? You have to multiply by this 1.6 into 10 to the power minus 19. And this is actually you have cube also, right? Because delta E ki power cube. So this should have cube also. Okay. So if you calculate this, you'll basically get 0.67 into 10 की power 12. क्या इसका कोई यूनिट होगा? हाँ? Will there be any unit of this ratio B21 by A21?
No, sir.
अच्छे से चेक करो, दोनों का सेम है यूनिट? हाँ? Just check it. दोनों का यूनिट सेम नहीं है. If you calculate this unit will become meter cube, joule inverse, second inverse. Meter cube, joule inverse, second inverse. Please check that unit. Okay, they have different unit. इसका आपका क्या होता है बेसिकली सेकंड इनवर्स होता है बट इसका डिफरेंट होता है चेक करो यू विल गेट डिफरेंट यूनिट so this is all about I mean whatever discussion we have done till now so we have solved these few problems so from this topic you will get the question in CSIR net like this now we are only discuss if you remember we have only focused about two level system E2 and E1 now I am saying the two level system cannot give you population inversion. You cannot achieve population inversion from two level system. At least we need three level system to achieve population inversion. So now we'll prove that if you have only two level system, it is not possible to achieve population inversion. So heading will be population inversion cannot be possible by two level system. So this I'll prove from or by using Boltzmann distribution law. Suppose you have a two level system E2 with number N2, E1 with number N1. And suppose their separation is delta E equals to H cross omega. Now if I use that Boltzmann distribution law, ratio of their population N2 by N1 that will be how much? कितना आ जाएगा? अभी हम लोगों ने डिस्कस किया था कितना आ जाएगा? Can you please tell me? Can you hear me? Please tell me how much you will get that ratio. You have a two level system and E2 and E1 with separation delta E equals to H cross omega. And
e to
suppose
power h cut omega kbt.
and suppose this system is having temperature T. So ratio of their population it will be how much exponential minus delta E. Delta E is how much H cross omega by KB into T. So it means 1 by exponential H cross omega by KB into T. Okay. So this is the N2 by N1. This is the ratio, right? Okay. So N2 by N1, it will be maximum. कब? N2 by N1, this will be maximum when नीचे वाला जो denominator में है, when that exponential this term will be minimum. This term will be maximum when denominator term will be minimum. And denominator में आपका है क्या? Exponential h cross omega by kbt. So exponential this term. Okay. So this term will be minimum कब? So what I am saying, N2 by N1 that will be minimum. N2 by N1 it will be maximum. It will be maximum when this denominator will be minimum. Okay, when this denominator is minimum, and this denominator is minimum when that exponent power is minimum. When that exponent power is minimum. Again, I am repeating N2 by N1 that will be maximum when right hand side denominator will be minimum. And when this denominator will be minimum, when exponent power is minimum. And the minimum value of this power will be how much? Anyone, can you please tell me कितना minimum possible है? जो exponent power है, how much will be the minimum possible value of this power? So you can see here omega is positive, h cross is positive number, omega frequency, this is also positive number, kb again it is positive number. When we are dealing with laser, temperature cannot be negative because you have to pump that system. So that in such a situation that system will have very high temperature. We already have discussed. We are discussing with T equals to 1000 Kelvin. So all the quantity h cross omega kb t all are basically what? Positive number. But you have to minimize this number. Then how much will be the minimum value of this term so that denominator term will be less to achieve n2 by n1 large? ये कितना minimum possible है? Exponential h cross omega by kbt. What will be the least possible value of this power? जब ये power least हो तभी ये आपका total term आपका least होगा, है ना? When this term is minimum, you will get n2 by n1 large. So this can be minimum value of this term can be possible, that is 0 when temperature of your system is infinity.
Infinite.
At this situation, what will happen? That exponential 0, that is nothing but on. So on by on will be how much? On. So maximum ratio of n2 by n1 that is possible, that is on. So you can achieve n2, maximum n2 that can be equals to n1. मतलब ये maximum possible हो सकता है, but you will never achieve population inversion. Population inversion करने के लिए क्या जरूरत है आपका? That for population inversion n2 should be greater than n1. But when you will have two level system, maximum n2 possible that will be equals to n1. So it is not possible to achieve population inversion from two level system. Is this clear what I'm saying? So at least we need three level system to achieve population inversion, and we'll understand in that next class how it will help if we have three level system, then how it will be helpful to achieve population inversion. So tell me if you have doubt. Tell me if you have any doubt on this.
So it means in two level we can never achieve population.
It is not possible to achieve population inversion, and two level system, from two level system will never get laser light.
Sir.
Okay, so whatever laser that is exist in nature, that is either 3 level, 4 level, and so on. From 2 level, it is not possible to produce laser because you are not able to achieve population inversion. Then how it is possible to get laser?
Sir,
Yes.
so the last part we have explained no, that t equals to 0 and t equals to infinity. Please explain that one once again.
Yes. So this formula you are familiar, right? That ratio of population between.
Yes, sir.
Now the maximum value of n2 by n1 कब पॉसिबल है? ये आपका क्या है? इधर आपका राइट हैंड साइड में क्या है? ऑन बाय एक्सपोनेंशियल h क्रॉस ओमेगा बाय kbt, राइट? तो मैक्सिमम n2 बाय n1 कब पॉसिबल है? जब आपका डिनोमिनेटर में जो टर्म है दैट इज मिनिमम, है ना? जैसे आपका ये मैक्सिमम कब पॉसिबल है? जब ऑन बाय समथिंग, ये डिनोमिनेटर वाला जब आपका छोटा होगा तभी तो ये आपका टोटल मैक्सिमम होगा, नहीं?
जी सर, ठीक है।
ओके, अब ये मैक्सिमम कब होगा? सॉरी, ये मिनिमम कब होगा? जब आपका एक्सपोनेंट पावर जो है ये मिनिमम होगा भाई। एक्सपोनेंशियल x, दिस विल बी मिनिमम कब? इसका वैल्यू मिनिमम कब होगा? जब आपका x मिनिमम हो। अब मिनिमम x कब कितना पॉसिबल है? यहाँ पे चेक करो। मिनिमम x नेगेटिव पॉसिबल नहीं है, क्यों? क्योंकि h क्रॉस पॉजिटिव नंबर, ओमेगा फ्रीक्वेंसी दैट इज पॉजिटिव नंबर, बोल्ट्जमैन कांस्टेंट पॉजिटिव नंबर, and you are dealing with system having very high temperature, like when you are achieving that, you are doing that pumping, So for laser, it is not possible to achieve negative temperature. So all this quantity are actually what? They are positive number. So minimum value of positive number that is possible कितना possible है? Minimum positive number कितना possible है? 0 possible है. And this 0 will be possible कब? जब आपका सिस्टम का टेम्परेचर इंफिनिटी हो. तो तभी तो आपका जो आपका 1/t, जब t इंफिनिटी हो तो 1/t 1/infinity that will be 0. So this whole exponent power will be 0 जब आपका t इंफिनिटी हो. जब आपका t इंफिनिटी हो, when t is infinity, this whole power will be 0. Okay. So maximum
Okay, sir.
value आपका n2 possible है, that is n1. कब? जब आपका सिस्टम का टेम्परेचर इंफिनिटी हो तभी पॉसिबल है. ओके. So this is I mean interesting. Next class we will discuss about that optical resonator, and this is also important part of your in exam point of view. Okay. So we will discuss many things about that. So if you have question, you ask me. Otherwise, I'll stop here. Okay. If you have no question, I can stop here.